Hey guys, this is Taylor and today we are solving the third problem of weekly contest 463, which is minimum sum after divisible sum deletions. Okay, so let's quickly see what is given to us. We have been given a nums array and integer k, and what we can do, we can perform repeated operations on any contiguous subarray. Okay, so we can our array size is this, we can perform an operation on contiguous subarrays. Contiguous means sequential arrays. We can't skip elements in between. What is the criteria? So that part, that contiguous subarray part, that sum should be divisible by k. If it is divisible by k, then I can perform some operation. What is the operation? I can basically delete it. Okay. So after each deletion, the remaining elements close the gap. That means that if that part is removed, so that sum will be also removed. So remaining element will be having only sum left with them. Okay, so return the minimum possible sum of nums after performing any such operation. So we can perform any number of operations. There is no limitation in that. And after performing all of the operations, we need to minimize our answer, minimize the sum in our array. Okay, so that is given to us. So if we see example, so here example is given. So k is 2, right? So if I add this to 1 comma 1, the sum is 2. So I can basically take it and remove it. So my remaining array will become this 1. And I think there is no way to remove this. So this is the minimal sum which is available in this array, which will be our answer. Okay, so we need to return a sum. So whatever, let's say 4 elements are remaining, so we need to return the sum of those 4 elements. Okay, so in this array, if we see that, I think 3 is divisible by 3, so that will be removed. Again, 141 is divisible by 3 because its sum is 6 and 6 is divisible by 3, so I can basically take it and remove it. So the remaining array will become 5, and 5 is not divisible, so we can keep it. So our answer is 5. Okay, so let's see what we can do, how we can solve this problem. Let me bring one test case for you. Okay, so here is my example. So if we talk about any brute force way to solve this, so we can use a recursive way of DP, which will be our brute force, in which we will have a two combination like take or not take. If sum till now is not divisible, we will either take it or not take it. If you are familiar with TP, then you may try it, but we will not get into it because that will not help us in solving this problem, because complexity of that is, I think, 2 to the power n, and with memoization and all, I think it will go up to n square, but space complexity will be very large. So we will not be going into that, but that will be again a brute force approach. So after solving brute force, basically, how we can solve this problem? So in this problem, what we need to do? Okay, we need to basically find any subarray. Okay, the first thing is we need to find a subarray. Okay, and if that sum is divisible by k. Okay, if that sum is divisible by k, if it returns a 0 on doing modulo, then we can remove it, right? We need to figure out this thing. So we have some previous questions in Leetcode itself, which is kind of similar pattern, which are based on, I think, prefix sum. Okay, so in those questions, I will put those two questions in description. Okay, so first question is based on, I think, simple sum wala thing. Okay, that will give you some intuition behind okay, how prefix sum will work in this question. If you are familiar with prefix sum, you can skip the first question. Okay, you can skip this. But second question, I will definitely recommend you. So there is two steps. Okay, to solve this problem. There is step one and there is a step 2. Okay, we will talk about both the steps, but after completing this step 1, I will highly recommend you to go and solve this second question. Okay, second question, which is given in the description. That after learning this step 1, you will basically able to practice this step. Once you are strong in this step now, then you can go ahead and write this step 2 of this solution. So that will definitely help you get like deeper insights of how you can come up with solutions like this. And second thing is like basically how you will be able to get better understanding of the question itself. Okay, so we can start the solution. Okay, so what we need to do in this test case, basically, let's see. In this question, let's see. Okay, so what I have done here, basically, I have calculated all the prefix. Okay, prefix sum. Prefix sum, if you don't know, So if we have 2 here, we wrote 2. Okay. After that, we just add this part and we will calculate this. 2 plus 5, 7. Then 7 plus 3, 10. 10 plus 7, 17, like this. Okay. What prefix sum is, basically we will just try to calculate all the sums. So like 2, then 7, we will just add this. Whatever number is here, we will add this and we'll get a new number, 10. Whatever number is here, we will add this in current number and we get a new number. Like this, I have calculated all of the prefix sum. After calculating all of the prefix sum, we are discussing step 1. Okay, we are discussing step 1. So step 1 is very, very important to solve this problem. Okay, in this sum module, okay, what I have done, whatever this sum is, okay, whatever this index sum, I am just trying a modulo. I am just trying to get a remainder. Okay, so I think 2 modulo 4 is 2, 7 modulo 4 is I think 3. Okay, and 10 modulo 4 is I think 2. So similarly, I have written modulo for each of this. You can verify by pause the video. You can verify this sum and this modulo are correct. Super. Now what is the observation here? In this there is a pattern. Okay, if you don't know, okay, how we can come up with solutions like this. So if you try to solve this second question now, you will get to know that there is a pattern which is based on prefix sum. So if you get something like this, okay, you have to find a sum of subarray, and you need to check either divisibility, either modulo, either you need to count something, either you need to like any such related stuff. So you need to use prefix sum in those cases. Okay, that's why I'm recommending you. So this question 2 and question 1, this question 1 and question 2 are basically prerequisites to these questions. If you are able to solve these problems, then you will be able to come up with solution like solution for these problems. Okay, super. Let's start the computation. Okay, we are just basically trying to recompute these values, and we'll see that how we can go to step 1 basically. Super. So let's start. I got a 2 here. My prefix sum is equal to 0 for now. I got a 2 here. I calculated 2 as my sum module. Okay. Okay. Now I came here. I will calculate new prefix sum. How I will calculate? What is the last prefix sum? I will add the new current element. I will get a new prefix sum. What is the remainder? I think 3 is the remainder. So what I need to check? I need to check whether I got a 3 in previous. I don't think we got a 2, we got a 3. Superb. So I will go here. I will calculate this. I will get a new prefix sum. I'll try to use this prefix sum modulo k. Okay, I will got a 2. Now this time I got a 2 here. Okay, and when I was checking, did I get a 2 here in the last? I think yes, I got a 2 here. Does it revealing anything? I think yes, it is revealing anything. If you carefully observe now, what does that mean? If I am getting a modulo 2 here, okay, if I am getting a remainder of 2 here, I'm getting a remainder of 2 here here as well. So that means after this, okay, after this, I was getting here, right? I was getting here. After this term, the sum of these two arrays, the sum of this part, 5, 5 and 3, that must be divisible by 4. That must be divisible by 4. This is the rule, okay? So if you solve problems like this, you know. Otherwise, you can observe this. Okay, we can go ahead also. So I got a 10 here. Now I will proceed. I will do a 7 addition. I will got a 17. Okay. I got a 1 here. Super. Did I see 1? No, I didn't see. Super. Now I will add a 4 here. I got a 21. I again get a remainder as 1. Did I see 1 in previous? Yes, I did see. I did see. What does that mean? What does that mean? So that means here I see 1, right? Here I saw 1. So after this, till the last index, the sum is divisible by 4. Okay, 4 modulo 4 equal to 0. So that is this thing. Okay, now again, let's continue. So 17 plus 4, 21 we got, then 21 plus 4, 25. Now again I got a 1. Okay, did I see 1? Yes, I saw 1. I saw 1 two times. Let's see, let's analyze both places. So what is our rule? So if we got 1 here, after this, okay, after this, okay, what is the sum? 8 is the sum. 8 is sum. 8 is 8 modulo 4 equal to 0. Yes, it is. Yes, it is. Okay. Now I saw 1 here as well. So this is the rule, right? After this, my sum should be modulo 4 modulo 4 would be 0. And this is true. This is true. Yes. Okay. Now let's again see. I got here 25 plus 6, I think 31. So what is the 31 modulo 3? I think 31 modulo 4, I think 3 is the answer. Did I saw 3 previously? Yes, I did see. I did see. Okay, let's verify the rule. I saw the 3 here. Okay, so I my rule says after this, if we compute these values, including this. So first one we are not including. The last place where we saw we are not including, but we are including the current wala thing. Okay, so when we include, let's try to calculate the sum. 3 plus 7 plus I think 4 plus 4 plus 6. 3 plus 7 10, 4 plus 4 8 plus 6. So 16 plus 8, how much? I think 24, right? 20 is 24 divisible by 4. Yes, it is. Yes, it is. Okay, so our rule is getting verified. Now again here, I saw it too. So I hope you got it. You can try run for this and this as well. Otherwise, video will become unnecessary very long. Okay, so I hope this much intuition is like so. This is basically the step one. What we have observed in step one says that if I get a reminder again, so like this is the best example. If I get a reminder again, okay, if I get a reminder again, the same reminder, that means that after that step, my sum is divisible by 4. For from whatever term I am taking the divisible reminder, that means that the sum after that, and sum including the last wala part, that sum is divisible by 4. This is my observation one. Okay, this observation will help us to solve problem step two. I hope that is clear. If you have any doubt in this step, just let me know in the comment section. Okay, now let's move to step two. So jumping to step two, one thing if we notice that our question says that if I got sum, okay, so here in this array if we see, so we got 3 as a sum, right? 3 as a sum. As soon as it is divisible by 3, I need to remove it, right? I need to remove it. That means if I removed it, okay, let's diagram that part, okay. So my array is I think 3, 1, 4, 5, okay, 1, 4, 1, 5, so and okay. Now I came here, I got a 3. As soon as this term is divisible by 3, okay, as soon as it is divisible by 3, I can remove it. I can remove it. Okay, so there is no issue to keeping it. There is no issue in removing it. Why? Because it will not help us in like future. It will definitely not help us. We can like the best strategy is to remove it. As soon as we got something which is divisible by k, we have to remove it because like something you got like let's say you got a 6, okay. So like whatever the next arrays are not plus, whatever next array like let's say 1 5 2 3 whatever it is, okay, that will not help. If this is divisible it will come out. If this part is divisible, this will come out, but if this part is not divisible, this 6 will not help in this part, okay. So as soon as we are getting something we should definitely remove it, okay. So that thing you got, I think, right? Okay, so okay, super. So I was here, right? So as soon as we got something, we have to remove it. Super. Now, if I remove it, what will be my current sum? We are calculating prefix sum, right? We got a prefix sum of 0 here. Now, as soon as we reach here, we wrote a prefix sum of 3. Now we saw that this prefix sum is divisible by 3. So can I say that I can make it to 0? Can I say this? Yes, I can say yes. I can definitely say. So let me make a 0 here because I'm considering that I have removed this. Okay. Superb. Now 0. I came a 0. I got a 1. I will write it here a 1. Superb. Superb. Now I got a 1 here. My prefix sum. I will go for it becomes 5. Okay, it becomes 5. Superb. Now what is my last prefix sum? I think 5. I will go here. I will edit. I got a 6. I got a 6. Okay, I got a 6. 6 modulo 3. It's what it is. It is 0. It is 0, right? As soon as I got something which is divisible, I will remove it. Let me make it 0. Let me make it 0. Okay. As soon as I'm getting something useful, I'm making it 0. Okay, then again I will got a prefix sum of 5. This thing you understood, right? Why what we are doing? As soon as we are getting something which is divisible by our k, we are just making some at 0, some 0 at that place, okay. So this is basically the intuition to solve the second step. Let me rewrite this, okay. We will keep this part as it is. Let me rewrite this here, okay. So what I have done, I have copied the exact same thing here, okay. And I have removed this prefix sum because we will be recalculating this prefix sum, okay. After like the observation that we did here, now we will recalculate this part. And the second thing is this sum modulo k will be remaining as it is. We will see this part as well, okay. So let's try to focus on this. and we'll try to calculate this. Okay, so I got a 2 here. Okay, now I come here, I will add it, I will get a 7. Okay, just to maintain something clean, I will not make these arrows. So okay, so I came here, I got a 10 here. Now I saw my remainder is 2. I saw this remainder, I saw this remainder. So from the step 1 and from the explanation that we discussed here, what I can conclude from this, I think some of this 5 plus 3 is something which is divisible by 4, divisible by our k, right? It is divisible, yes. So can I make a sum equal to 0 here? Can I make it? Can you guys tell me? Can I make it 0? No, I can't make it. But can I make it 2? Can I make it 2? Why? Because see, the sum 5 plus 3 is equal to 8 here. Okay, is equal to 8 here, and 8 is divisible. So sum between this subarray, we have to deal in subarrays, right? So if I remove this part, and my remaining subarray will be 2, 7, 4, 4, 6, 2, 1. Remaining subarray is this, right? So if I try to calculate prefix sum of this, prefix sum is 0, then I calculate like this, 2, then 7, then I'm getting 9. So 7, what is the input to 7? Input to 7 is 2, right? Why it is 2? Because there is some term in here, 5 comma 3, which is divisible by 8, which is divisible by 4, and which is removed. Okay, I hope you are able to understand. Why we are so can I make 2 here? Okay, so I will write with orange. I will cut this and I will make it 2. Why I have made this 2? This is like very, just carefully understand this, because there was some array. Okay, there was some array. This part 5 plus 3, it was getting me at, and we saw that as soon as we got something which is divisible, we can remove. Okay, the remaining subarray we got 2, 7, and 4, 4, and so on. Okay, so as soon as I got something, I have removed this. So what is the remaining prefix sum? 2, then 9, then 13, like this, right? So I hope I'm able to explain you. Okay, so I think I can make this 2, because step one is saying that this is divisible. Step 2 is saying that as soon as you got something divisible, remove it, and go to the last prefix sum, go to the last sum that you got. So according to this, I got a 2 here. I saw that on 2, I'm having a better prefix sum. So now let's focus on our problem. In our problem, what we need to do, we need to minimize our remaining sum. And what is the remaining sum here? If I talk about only this part, okay, if we have only this array, okay, 253, what is our answer? Our answer is definitely, we know, okay, 5 plus 3 is 8, and 8 is our answer, which is divisible by 4. That's why our remaining sum is 2, and we can't do anything for this. But how this answer comes? We got a 2 prefix sum, we got a 7 prefix sum, we got a 10 prefix sum. When we calculate remainders, I think this is 2, this is 3, and this is 2. When if we got again, okay, so we saw that on remainder 2 we had a prefix sum of 2. What does that mean? If so that mean, array, okay, it got wrong. Let's discuss here. Okay. Okay. So in this we got a prefix sum of 2. If this prefix sum is 2 already exists, that means that remainder is coming again. That means that part is all actually divisible by k, and if it is divisible by k, I can definitely remove it. Okay, and if I can remove it, whatever prefix sum present there at that time, I can just copy paste it. Okay, so that simple thing we are doing here. Okay, now again I will do the same thing. Okay, again I will do the same thing. I will go here, I will go to 7. I will say, can you give me what is the prefix sum? I think 2 plus 7, it's 9. Okay, it's 9. Super. Let me write 9 here. And I got a 1 as a remainder. Remainder will not change. Okay, so what is 9 modulo 4? 9 modulo 4 is again 1. Okay, if I go further, this remainders will not change. Okay, this is the rule. Super. Now I will go here. I think 9 plus 4 is 13. Okay, 13. Let me write 13. Now, did I see 1 here? I got a 1 here. Did I see 1 here? Yes, I think yes. I saw 1 here. Okay, I saw 1 here. And what is my current sum? My current prefix sum is 13. Okay, my current prefix sum is 13. Superb. Now, I saw 1 here. What does that mean? That means that some part is divisible. This part is divisible, right? So I can remove it. So what I can get? if I can remove this part, can I get 9 here? Can I get 9 here directly? I think yes. Yes, why? Because if I remove this, what is the sum till now? Sum till now. I think sum till now is 9. So I can definitely get a 9. And you, if you see now, if you observe, this 5 and 3 is already implemented. If it's already implemented, because when I was calculating this sum, when I was calculating this sum, okay, this 9, I considered this part, and if I considered this part in this sum, so whenever I reuse this 5 comma 3 will be reusing. Okay, so I think this is the best time to write this DP array. So what we will be maintaining? We will be maintaining a DP array. I hope you are getting it right. So just to make our calculations easy, so we will be having, we need some way, right? Okay, we got a 1 here. How we'll be checking that whether this 1 exists or not? Previously we found 1 or not. So we will do something like this. I think DP array should be small. Just a minute. 1, 2, 3, 4. Super. And array indices will be 0, 1, 2, 3. So whatever our case size is, our DP array will be of that size. Okay, because we will either get 0, either get 1, either get 2, either 3 remainders. We will not never get 4 or greater than 4 remainder as a remainder, right? So what we had seen so far, we had seen that I think I can use green. So for 0 I will make a 0, and for rest of things I will make a infinite. Okay, what does that mean? 0 means ki if I got a 0 sum, if I got a 0 sum, that means my sum is 0. So what does that means is, let's say I got a 2, then again I got a 2, so my sum is 4. My sum is 4. If my sum is 4, that means this 4 is divisible by 4. So did I get any remainder? I think no. My remainder is 0. That's why. Okay. We are maintaining a 0 here. Now, what I had seen so far. So for 2, for remainder 2, I was getting 2 as the best answer. For 2, I was getting 2 as the best answer. Let me mark it 2. Super. Now for 1, I got a 9 as a best answer. Okay. Let me mark it. For this, was this 13? I saw that I already had a 9. I already had a 9, which is better. So I will just make it 9. Okay, super. Now let's see. Let's see further. So I got a 9 plus 4. I think 9 plus 4 is again 13. So again I will check. Do I have something better? No. Yes, I sorry. Yes, we are having something better. So let me again make it 9. Super. What does that mean? What does that mean? That means that so here we got a 9. Here we got a remainder of 1, and we got a sum of 9. What does that mean? This part is divisible, so I can definitely remove it, and whatever sum present I will just move it here. Okay, I think you are getting what we are trying to understand. Superb. Let's move further. Let's move further. Superb. 9 plus 6, I think it is 15. So this will remain same. So 15 modulo 4, just check, it is 3. It is 3. 12, and then plus 3, we'll got a 3 as a remainder. Superb. So 15. Did I saw 3 previously? Yes, I did so. I did so. Where it is? I think here. What is the rule? What is the rule? This part sum will be 0. This part sum will be 0. Okay, superb. What is the best answer at 3? I think best answer at 3 is 7. I forgot to put it. Okay, it's 3. It's 7. Okay. Best answer at 3 was 7. What is the best answer at 15 till now? At 3 currently. I think it is 15. So I am having a better previously. I am having a better. So why not to take it? Definitely I will take it. Superb. Let me take it. So okay. It yeah. So can I make it this 7? What does that mean? If I make this 7, that means I have removed this part. I have made this, I have selected this part, and I got that okay, this part is basically divisible by 4. So I have removed this. If I have removed this, so this part will be nothing. This sum will be nothing, and here when I will calculate for this 2 na, I will get us this 7. This 7 plus 2. Okay, that's why I'm maintaining a 7 here. Okay. I hope you got it. Super. Next thing. 7 plus 2 is 9. Did I saw 1? Did I saw 1 previously? Yes, I did so. I did so. What is the best answer? I think 1 is the best answer. 9 is the best answer. Currently it is also 9, so no need to do anything. Super. Let me go ahead. Let me go ahead. Super. Now I got a basically 1 here. Okay. Now 9 plus 1 is 10. 9 plus 1 is 10. Superb. Now let's see very carefully. This is very important step. I got a 2 reminder. Did I saw 2 previously? Yes, I did saw 2 previously. Now, what is the case? this part, what does that mean? This part, sorry, not this, I mean this part I can definitely remove because that is divisible by 4. How this is divisible? 5 plus 3 is 8, 8 plus 7 is 15, 15 plus 8 is I think 23, 23 plus 6 is 29, 29, 31, 32, and 32 modulo 4 is definitely a 0. Okay, that means that I can definitely remove all this part, and I was getting 10, but previously I had stored 2 here. So what I will do, I will directly make it 2 here, right? I will make it 2. Super. Now there is one more thing that if let's say for example, in any case, let's say कि we didn't get a better here, but we get a better here. Okay, let's see. Let me write a dummy kind of thing. So I have created this example just to understand that we need to update these DP values as well. So if I got something better here, let's say okay, here we were getting every time better is present in DB, but we can get better in this place also. So that in that case we need to update this DB. So let's try to mimic that. So here I got a one. Okay, I got an infinite. I got an infinite. So here I am getting a prefix sum of 13. Can I update this? Definitely I can update this because this is infinite, and at 1 I'm getting 13. So definitely I can update it. Super. Now here I'm getting 3 as a remainder. At 3 I'm already having an infinite. Can I update this as a 15? Yes, I can update this. Super. So I came here. I got a 16. I got the exact number. That means it's like this part is 0, this part is 16. So can I update it this time? I need to update this. Super, super. Now let's see. So if this is 0, if this is 0, can I make this 1? Can I make this 1? Yes, I can make this 1. This 17 is no longer the correct answer. 0 plus 1 will be the 1. This is the new prefix sum. The same thing that we were doing here, because this part is actually divisible by 4. So I will whatever sum present here at some 0 I was having 0. Okay, so that's why I made a 0 here. Super. So 0 to 1, I got a 1 here. Now at remainder 1, what is my current prefix sum? 13 is the prefix sum. But do I am having something better? Yes, I am having something better. So let me update this to 1. So in such examples, what is the case? So we need to check both things. Okay, first we will check key whether DP array is having some better. So then I will update this. Okay, and if this sum is better, I will update DP array as well. Okay, that is important step. I hope you are able to understand what we are doing and why we are doing. So the approach is simple. Okay, if you are not able to understand this second part, there is no issue. In code you will definitely able to understand this, but main part is this. Okay, if you are able to understand that why we had removed this, because sum of this is equal to something x, which is divisible by 4, and we had completely removed this, and whatever sum present here we just pushed this sum here, pushed that sum here, and that's why we got a 9 here. Okay, if you are able to understand this approach, I think this should be this should be 2. This why I don't think this should be 2, I think. Okay, no, sorry, it's correct only. Okay, so whatever sum is present here, 7 plus 2 is 9, it's like that. So whatever sum is present here, sorry, my bad. I got a 3 here. Okay, whatever sum is present in this part. Okay, whatever sum is present in this part, I just copied that part here, 7, and 7 plus 2, 9, I got like this. If you are able to understand this part now, then you are able to solve this problem. So let me write quickly the pseudocode for this approach. Okay, so pseudocode will look like something like this. So code will be very simpler. Pseudocode will be very simpler. I will maintain some prefix sum, okay, which I can initialize from 0. I can maintain a DP array where all values will be infinite and it is of size n, where n is length of nums. Superb. And DP of 0, I can definitely make a 0, as we see that if 4, I got a 4, okay, as a first element. 4 is divisible by 4, so I can get a 0, right? So that's not a problem. So I can start from I equal to 0 to n minus 1. What I need to do, I need to just increment my prefix sum first of all. Okay, prefix sum plus equal to my nums of I. So that's what the same thing that we were doing here. 2 plus 5, whatever prefix sum is here, my prefix sum was 0, so 0 plus 2, I got a 2 here. Now what we need to do next thing, we need to calculate the remainder. Okay, so remainder equal to whatever prefix sum is, prefix sum modulo k. Okay, superb. Now what is the next thing? I need to just compare. Did I saw this remainder previously? So let me check. So I can directly update it something like this: prefix sum equal to minimum of, okay, whatever the prefix sum is, whatever my current prefix sum, comma, dp of remainder. What does that mean? That means that whatever remainder I am getting here, if I saw something better now, for now it was infinite. If I saw something better, that will be came here. Okay, so the step that we were doing here, right? So we removed this 15 and we moved this 7. So that is basically, if this 15 is minimum, then 15 will be present. If this 7 is minimum, so this 7 will move here. Okay, they will move here. That's what we are doing here. Superb. Now what is the next thing? I need to update dp also. Okay, so dp of remainder will be minimum of, in case let's say, okay, I got something like that, prefix sum becomes, I think 1. I think 1 became here, right? So I need to cut this 13 and I need to make this 1, because this 1 can help me in future. Okay, in future it can help me. So I have to maintain this thing also, so I will maintain. So if dp of remainder is already minimum, then not a problem. Otherwise I will make a prefix sum as my minimum. Okay, and I think we are pretty good. So in last we can definitely return our prefix sum as answer. Why prefix sum as answer? Because that is the last part that is storing our current answer. So if I got a 2 here, that means that I am removing all these numbers, and whatever number here, it came here. So that was my answer. If here I got a 1, how I got a 1? All of the numbers were removed, and what is the remaining, I got here. So this prefix sum, I am getting it. Let's quickly write code for it. I think writing code and pseudocode is easy for this question, but understanding that part is very important. Okay, that just focus on that part. If you didn't get it properly, I will recommend you to rewatch the solution. And what I can do is, what I can say is, if you are not good in prefix sum and this logic, na, I will highly recommend you, after learning this step 1 and step 2, solve the question 2, which is present in the description. Okay, that will definitely help you and give you motivation. Super. So length of nums, let's quickly write code for this. I think prefix sum will be 0. And I think, do I need to initialize anything else? Okay, dp I need to initialize. Dp equal to, all value will be infinite, and dp of 0, I can definitely make a 0. Okay, now I need to iterate over all of the nums. What I need to do, I need to first of all increment my prefix sum. Okay, what is the next thing I need to do? I think uh, the next thing, I need to calculate a remainder. Remainder equal to whatever my prefix sum is, I will take a modulo of k. Super. Now I need to check whether my can I update my prefix sum, because like, do I have a better answer in my DP? So prefix sum equal to minimum of prefix sum, comma, dp of remainder. What does that mean? If for this remainder, if I am having a better prefix sum in dp, just get that. Otherwise, if I am having better prefix sum, then I can update dp as well. That's not a problem. Minimum of prefix sum, comma, dp of remainder. Okay, and in last I can just return my prefix sum as answer. So this problem is little tough if you are not able to understand this part well, but if you understand this part well, ki why, what we are doing here, if the sum is 0, that's why we are removing this and we are just putting this part here. then you will be definitely able to understand and write code for this. And write code is very, very simple if you can see. Let's try to submit this tough problem. We got an error. List index out of range. DP of remainder. Okay, sure. I think it should be K. Let's try to submit this now. I have used this test case as well. Let's try to submit this. Okay, let's try to submit now. Yes, it is working fine. I hope guys you are able to understand, and if you are able to understand still, I will just highly recommend you. I will put the question 1 and question 2 link. Make sure you watch you solve that problem, because that is basically that problem is easier than this, but that will give you motivation. Okay, so you must be fine, you try to find similar questions, right? So just go and solve that problem. That will definitely help you in understanding what is the logic behind this prefix sum and this modulo arithmetic. Okay, so that's all for this video. If you are able to understand this detailed solution, I will highly request you to please subscribe the channel and give a thumbs up if you can. That will definitely motivate me to create more such insightful videos and in detailed solution, where we discuss not just the solution but approach, how to basically targeted approach, what is the similar questions we can solve. We divide solutions in steps. Okay, so that is lot of efforts. So thank you very much guys for watching this video, and we will meet in the next one. Thank you guys.